Hello everyone, welcome back to the channel. Myself Akshay Mishra, and in this video I'll upsolve the problem Alice Potter and Dumbledore from CodeChef Cookoff Challenge February. And let's read the problem statement. So Dumbledore's army consists of n members, and Alice Potter is planning to hold m Dumbledores army sessions where the members will perform training tasks to improve their skills in defense against the dark arts. Initially, each member of the army has no tasks. Before the IAT training session, Alice gives the PIth participant a task that he can complete in TI seconds. So we would be given some list of participants and the list of their tasks, and in each subsequent session Alice will add more and more difficult tasks where TI is less than equal to TI plus 1. So after every session the tasks will get harder. They'll actually be either greater than the previous task or would require the same time as the previous task. So we have to assume that the ith session the jth participant has accumulated CJ tasks. Alice knows that sometimes there is not enough time to complete all the tasks in a single session. So instead of forcing them to complete all C1 plus C2 to CN tasks, she can allow them to complete only a certain number K of them. In this case, each participant can choose a subset of their tasks. In total, they have to choose K tasks and perform only those tasks. Each participant perform his tasks sequentially and spends time equal to the sum of the times of his tasks. However, different participants can perform tasks in parallel, so the total time of the session is equal to the maximum of the times of each participant. We denote the minimum possible value of the this time by answer ik, and in order to optimally train participants for each session I, Alice needs to know the value of answer I1 plus answer I2 plus answer to answer II, and we have to help Alice calculate these sums for her. And in the input we will be given two integers n and m. N denotes the number of members of the army and m denotes the number of classes. The ith of the next m lines contains two integers, the participant number and the number of tasks. So I hope you might be overwhelmed by the huge problem statement given here. Even I also, that's why I couldn't solve it during the contest. But our job is to upsolve, so we'll do that. So as you can see in the input test cases, we were given this huge input where this line gives the participants, and this denotes the time taken by them to complete the task, or time they start from here. So in the first session our participant number 5 would be given a task which he has to complete in 1 unit of time. So our answer for that would be just 1. And in the second session our third participant gets a task which he has to complete in 2 units of time. So here we'll add 2. Okay, now to get the answer for this question, first for the first session only 1 would be the answer because we require only 1 task to complete. For the second session, for completing 1 task, the minimum of 2 and 1 is 1, so the answer for that would be 1. For the, if we take session number 2 as our example, then for first session we require 1 minute to complete the task, and for completing 2 tasks we require maximum of these 2. Like these 2 tasks can run simultaneously, and the larger time would be taken by these 2. So for the second session the answer would be 1 plus 2, which would be equal to 3. similarly, for the third session, we are given that the participant number 5 has to complete a task of 2 units of time. So participant number 5 has been given a task of 2 units of time. Now, for if we take the third session as an example, then for completing one task, this task can be completed, so it requires minimum time. For completing two tasks, this one and this one can be completed, and it would require 2 units of time because this is a larger time, so 2 units of time. And if we want to complete 3 tasks, then this one would complete this task, and participant 5 would complete first this task and then this task. He can't do both simultaneously, so a total of 3 units of time would be required for the completion of this task. So answer would be 6 in that case. If we take the fourth session as an example, then 2 would be added. First participant, and then if we want to compute the time required for completing one by one each task, first the minimum of all the tasks would be completed, which is 1 unit, so 1 would be taken here. Then we'll add the time required to complete 2 tasks, so this task and this can be completed simultaneously, and maximum would be 2, so minimum time required would be 2. And similarly, if we want to complete 3 tasks, then we can ask first participant to do this task, third participant to do this task, and fifth participant to do this task, and it would take again 2 units of time. And if we want to complete all the 4 tasks, so these 2 can run simultaneously, it would take 2 units of time, but for fifth participant has to complete these 2 tasks which he can't do simultaneously, so first he would complete this one and then he would complete this one, which would require him 3 units of time. So that was the answer. If we want to compute the time required for the 5th session, then we would add first 3 to the value of 4th participant. So here we are computing for the 5th session. So again the same computation can take place. First we would require 1 unit of time to complete one task, then we would require 2 units of time to complete 2 tasks. Then again we require only 2 units of time to complete 3 tasks, and then for completing 4 tasks we can choose these 4 tasks, and this would be the max, so this would be added here. And for computing all the 5 tasks, we need to take this time, this time, this time, so up till now 3 units of time are required, and he will complete the task one by one, so for him also 3 units of time would be required. So the time which would be added would be 3 units, which would make up 11 units of time, and previously the answer was 8 units. So I hope that you are starting to recognize a pattern here. If not, then I'll show what the pattern is here. So for the first session our answer was 1. For the second session our answer was 1 plus 2, which was equal to 3. For the third session our answer was 6. For the fourth session our answer was 8. And for the fifth session our answer was 11. And if you see the test cases, then you would notice something, that from the previous answer, the next amount of the next participants whose task is given, then his total time is added to our final answer. Like if we take, I've noted down all the amounts of time which are added in each case. In the first session, only the fifth participant's time was added, because up till then only that was given. And in the second session, for completing one task, already 1 unit of time was required. And for completing 2 tasks, our total time of participant number 3 was added, which was 2 units. And for completing 3 tasks, first to complete 1 task, this was added. For completing 2 tasks, this amount of time was added, and which was previously given. And for completing all 3 tasks, we can easily observe that total time up till that point of participant number 5 would be added. And this is the same participant to whom in that particular session a task was given. We can again observe this scenario in the fourth session. For the first task, we can complete in 1 unit of time, which is here. To complete 2 tasks, we can complete it in 2 unit of time. To complete 3 tasks, we can complete in total 6 unit of time. And to complete all 4 tasks, we require 8 units of time, and 2 units of time of the first participant would be added here. And first participant was the one to whom the task was given at this stage of time. And we observe the same scenario here. 3 units of time are added to previous session, and these 3 units of time are of the fourth participant, and fourth participant is the one to whom the task is given in this session. So it's a clear indication that the current participant who gets some task, his time would be added to our original answer for every session. And that was the key takeaway in this question. And this was quite easy to figure out if you were not quite overwhelmed by the problem statement. But the problem statement was quite huge yesterday, and the contest too was Cookoff, which is a short contest, so it was quite difficult if you are a division 3 candidate in the contest to figure out the pattern. But with practice we can do so. So let's switch to the code of the problem now. The problem, and we'll take some as our the variable or array which stores every participant's total unit of time, and we have taken a large number. In the example 10 to power 6 was given, so I've taken that, and we'll take n and m as inputs. We'll store the answer which we have to print in each test case, and here the participant and the task time is taken as input. For the present participant, time would be added, and this time would add up to the answer, and this would be printed as observed in the whiteboard. So I hope you understood the problem and the code, and it would be quite beneficial, as I too was quite late to understand this problem. So it would be good if you also write it down somewhere and also code the problem, so that you will understand the problem better. I'll add the GitHub link to the code in the description, and you can watch the code too if you want it from there. And I hope you enjoyed the video and understood the solution. And if there are any doubts, you can write it down in the comment section. And thanks for watching, and please like, share and subscribe if you found the video helpful somehow. Thanks.